Welcome everyone. In this session, on Chapter 3, Fundamentals of Dyes and Dyeing Chemistry, we will focus on balancing cost and quality, helping color lab managers develop cost-effective, buyer-approved dye recipes without compromising quality. Section 4.1 discusses why balancing cost and quality matters. Dyeing involves controlling cost while meeting quality standards like color fastness. Overusing expensive dyes reduces profit, while cheap dyes can lead to costly re-dyeing. A balanced recipe ensures efficiency and reproducibility. In this example, we see cost versus quality in action for navy on cotton. Using a smart combination of a high-strength reactive blue and a supportive, economical blue achieves similar fastness at a much lower cost. Section 4.2 covers factors that influence dye cost. These include dye strength, shade depth, the number of dyes in the combination, the yield of the dyes, and supplier pricing. Section 4.3 outlines the quality requirements to meet. Even when reducing cost, standards for shade accuracy, wash fastness, rubbing fastness, light fastness, and reproducibility must be maintained. Failing quality means re-dyeing, costing more than any initial savings. Step 1 is to start with buyer quality standards. Check the buyer tech pack for all fastness and testing requirements before selecting any dye. These requirements set the minimum performance level for your recipe. Step 2 is to select dyes by function. We use a main dye for the body shade, supportive dyes to fine-tune the hue, and potentially a cost optimizer dye to replace part of the main dye for lower cost without sacrificing quality. Step 3 involves running lab dip trials. Prepare 2 to 3 options for every shade. Premium, high-quality dyes. Balanced, mix of premium and cost-effective dyes. And economical, lower-cost dyes for internal study. Step 4 is to evaluate performance. Before approval, check the color accuracy using the delta E reading. Review fastness test results and compare the cost per kilogram of fabric for all trial options. In this practical example of navy on cotton, we compare 3 options. The balanced recipe was approved, meeting the required fastness while reducing cost by about 21% compared to the premium option. Section 4.6 covers tools for cost-quality decision-making. These include a spectrophotometer for color accuracy, fastness test equipment, a dye costing calculator, and a dye database or shade library. Section 4.7 provides lab managers cost control tips. These include keeping historical dye records, working with suppliers on new economical dyes, avoiding overshading, standardizing recipes, and reusing approved combinations. Here is a quick lab cost-quality checklist. Review buyer fastness requirements, confirm dye strength, run an economical combination trial, check that delta E is within tolerance, ensure the fastness test is passed, and calculate and document the recipe cost. Key takeaways from Chapter 4. Cost and quality must be balanced. Smart dye combinations reduce cost without compromising fastness. Documenting results builds internal knowledge, and supplier collaboration can reduce cost by 5 to 15% on key shades. This concludes Chapter 4 on working with dyes, balancing cost and quality. Mastering this balance between cost efficiency and buyer-approved quality ensures every recipe becomes a competitive advantage. Thank you for watching. Let's now move on to the next chapter.